Okay, let's dive right in. We're talking about what is genuinely a revolution in medicine, using some of the most advanced AI out there to tackle one of the oldest, most difficult puzzles in diagnostics, Parkinson's disease. We're going to see how AI is basically becoming a team of digital detectives, finding clues that have been hidden in plain sight this whole time.
So first, let's just get a sense of the scale here, because this is a massive global challenge. More than 10 million people worldwide are living with Parkinson's. I mean, that makes it the second most common neurodegenerative disease on the entire planet, right behind Alzheimer's. So you can see, finding a better way to diagnose it isn't just some academic project. It's an absolutely critical need for millions of people and their families.
So what's actually going on inside the brain? Well, Parkinson's is a progressive disorder. At its core, it's caused by the loss of these very specific neurons that produce dopamine. And without enough of that dopamine, the brain's ability to control movement gets compromised. That's what leads to those classic motor symptoms you've probably heard of, like tremors, stiffness, and just a general slowness of movement.
Right, so that brings us to the big question here. If we have a pretty good idea of what's causing it, why is it so incredibly hard to diagnose it early on? I mean, this is the question that has really stumped doctors for decades, and it's exactly why this new technology is so desperately needed.
You see, the way we've traditionally diagnosed it, it's a real dilemma. It's slow, it can be pretty subjective, and it really depends on a doctor just observing a patient's symptoms over time. But here's the kicker. By the time those symptoms are obvious enough for a doctor to spot, the disease has already made significant progress.
Let's break down exactly why it's so tough. For one, the diagnosis often relies on these clinical rating scales, which have a level of subjectivity to them. Then you've got the fact that a patient might only see a specialist a couple of times a year, which can totally miss how their symptoms change from day to day. Plus, the early signs, like a slight tremor, can look like a dozen other conditions. And the big one? There is no single definitive test, no simple blood test or biomarker that can just say, yes, this is Parkinson's, especially in those crucial early stages.
Okay, so this is where our digital detectives finally enter the scene. We're talking about deep learning. See, instead of looking for one big smoking gun, these AI models can be trained to sift through massive amounts of all kinds of different data, searching for these really subtle patterns that are just completely invisible to the human eye.
And just look at this. This shows you the sheer breadth of their investigation. The AI isn't just looking at one thing. It's analyzing everything, from the sound of your voice, to the way you write, to brain signals, to data from your smartwatch. It can even find clues in the chemical makeup of your saliva. It's this truly holistic approach, and I want to dive into a few absolutely incredible examples.
All right, let's start with something you probably do every single day, writing. I know, it sounds a little like science fiction, right? But it turns out incredible clues about your neurological health can be hidden in the simple way you form letters on a page.
One of the classic, but often really subtle, early signs of Parkinson's is something called micrographia. It's this thing where a person's handwriting just starts getting smaller and smaller, more cramped. Now, a sharp neurologist might notice this, but an AI can analyze the pressure, the speed, and the size of every single stroke with like superhuman precision.
And the results? Honestly, they're stunning. In one study, they used a cool technique called transfer learning. That's where an AI takes what it learned from one task and applies it to a new one, to analyze pictures of spirals and waves drawn by patients. The model could tell the difference between people with Parkinson's and healthy people with over 95% accuracy. I mean, that is way better than even other AI models, which proves this thing is picking up on something very real.
But the clues aren't just in what you write, they're in how you move every single day. And get this, the tools to spot these signals, you might literally have one on your wrist right now. And this right here, this is a total game changer. Research confirms that the everyday gadgets we already own, like smartwatches, can be turned into incredibly powerful medical monitors. The sensors that are already packed inside them, the accelerometers and gyroscopes, are sensitive enough to track the subtle movement problems that are hallmarks of Parkinson's.
So how does this actually work? It's pretty cool, basically a three-step process. First, the smartwatch just collects movement data while someone does simple tasks, like tapping their fingers. Next, a special type of AI, a convolutional neural network, crunches that raw data and pulls out the most important patterns or features. Finally, another kind of AI, a random forest classifier, looks at those features and gives an accurate score for the severity of a key symptom called bradykinesia, which is just a fancy word for slowness of movement.
And how well does it work? Amazingly well. This combo AI approach gets what's called an area under the curve, or AUC, of 0.939. So In the world of diagnostics, a perfect score is 1.0. Getting a .939, that is incredibly good. It tells us this method is super reliable.
Okay, so we've had handwriting, we've had smartwatches, now we're going to get even more futuristic. Our third piece of evidence? A single drop of saliva.
So researchers have figured out how to analyze what they call a saliva metabolic fingerprint. Basically, using a high-tech method, they can map out the unique pattern of all these tiny molecules called metabolites in a saliva sample. Then, a deep learning model analyzes this super complex fingerprint, looking for the specific patterns linked to Parkinson's. And here's the crazy part. The whole test only needs 10 nanoliters of saliva. It's about as non-invasive as it gets.
And you know what? This method works really well. It's got a sensitivity of over 88%, which means it's great at correctly identifying people who do have the disease. It also has a specificity of nearly 80%, meaning it's also good at correctly identifying people who don't. That F1 score of over 0.8 just tells us it strikes a really fantastic balance, proving it could be a super reliable screening tool.
Okay, so we've looked at handwriting, movement, even saliva. Each of these is a really powerful tool all on its own. But the real breakthrough, the future of this whole thing, isn't about picking just one.
No, the real power is in combining all of them. This is what's called a multimodal approach. By pulling in data from all these different sources, you get this incredibly rich, super robust, and way more accurate picture of a person's health than any single test could ever hope to provide on its own.
And this table here lays it all out perfectly. Up top, you've got your traditional medical scans. Super accurate, sure, but not very accessible and pretty invasive. In the middle, you have things like EEG and the saliva test, still really accurate, a bit more accessible, and way less of a burden on the patient. And then down at the bottom, you have the super accessible, completely non-invasive methods like handwriting and smartwatch data, which are still posting incredibly impressive accuracy numbers. The future is probably using all of these in some kind of smart, tiered system, right? But there's a huge challenge we have to talk about. It's called the black box problem. An AI can spit out a highly accurate answer, yes or no, but oftentimes it can't explain how it got there. And for a doctor to trust that answer and, act on it, they need to know why. They need the reasoning behind the diagnosis. So, what's the game plan? How do we move forward? Well, there are a few key steps. We need to build bigger, better, and more diverse datasets to train these AIs. We need to develop what's called explainable AI to crack open that black box and make the models transparent. We absolutely need to foster way more collaboration between the doctors in the clinic and the data scientists building these tools. And finally, we need to standardize all these methods so they can be rolled out safely and effectively everywhere. But let's be clear, the potential here is just absolutely enormous. As the research puts it, this isn't just a small step forward, it is a transformative advancement. This tech has the power to completely change how we detect and manage Parkinson's, allowing for earlier, more personalized treatments that could dramatically improve a person's quality of life. And that really leaves us with one last huge question to think about. We've seen how this all works for Parkinson's, but is this kind of multimodal, AI-powered detective work the blueprint for how we're going to diagnose all complex diseases in the future? Could we use this same strategy to unlock the diagnostic secrets of all kinds of conditions? It's a really powerful thought.